today's session, we are going to discuss the typical method for testing a fuse. We are going to see the construction and working of a circuit breaker, and finally the PTC type of a circuit breaker we are going to see. So let's start this session. Now, for testing a typical type of a fuse, okay, as you have seen in the earlier lecture, that there is a transparent case above the fuse which shows us the internal elements of the fuse. So from this transparent casing, we can analyze whether the internal element is intact or it is broken. If this above coating of or the coating material, or we can say the casing of the fuse, is not transparent in nature, then we have to use equipment such as test light or a multimeter to test the fuse. And if the fuse is okay, there might be another fault in the system, that can be poor connection. So we have to see this one by one. The best method to test the fuse is by using a test light. The test light should be connected first to one side of the fuse and then the other. A test light should light on both sides. If the test light only lights on one side, the fuse is blown or open. If the test light does not light on the either side of the fuse, then the circuit is not being supplied power. Now, in this case, you can use a ohm meter to test the fusible link voltages. The next important concept for today's session is the circuit breakers. The circuit breakers are the protective devices which are used in our circuits. They are used to prevent harmful overload. Circuit breakers act by opening the circuit and stopping the current flow to prevent the overheating and possible fire caused by the hot wires or the electrical components. This circuit breaker is a mechanical component that is made of two different materials. We call it as a bimetallic. And there is a deformation of this material upon heating. So when it is heated, it opens the contact point and the current stops to flow from the circuit. There are cycling type of circuit breakers that reset when current stops flowing, causing the bimetallic strip to cool and again to circuit to loads. A circuit breaker is usually used in the circuits that could affect safety of passengers if a conventional non-resetting fuse were used. Now here you can see the construction of a circuit breaker. Now in this case, this is a bimetallic strip which is made by joining the two different materials, and in this case each material is having a different we can say constant for its expansion. When these materials get heated, these strips get expanded or contracted based upon this constant. Now, coming on to the use of the circuit breaker in the automotive component, the headlight switch is A common example where we are using a circuit breaker other than fuse. Obviously, a sudden loss of headlight at night could be a disastrous result. A circuit breaker opens and closes the circuit rapidly, protecting the circuit from overheating and also providing sufficient current flow to maintain at least partial headlight operation. Circuit breakers are also used in other circuits where conventional fuses cannot provide for the surges of high current commonly found in those circuits. Here are we can see the electrical symbols to represent the circuit breaker. So this one is an example, and also here also this is the example. So in the circuit diagram, these symbols represents the use of a circuit breaker which is used in that circuit. Now, next important concept that is called as a PTC circuit protectors. The PTC stands for positive temperature coefficient, and these are the solid state, and these are not getting melted. Like other circuit protection devices, PTCs are installed in series in the circuit being protected. If excessive current flows, the temperature and resistance of the PTC increases. Unlike the circuit breakers or the fuses, PTC circuit protection devices do not open but rather provide very high resistance between the protector and the component. So in other words, the voltage which will be available to the component. So there is a lot of misunderstanding about how this circuit PTC type of a circuit breakers works, but I will show you with help of a diagram. So here in this case, this is a particular type of a circuit breaker, PTC type, and that is used for the operation of a motor. Now, the normal operation of a PTC circuit breaker is in the power window motor circuit. When the normal current flow, the temperature of the PTC circuit remains normal. But when the current exceeds the amperage rating of a PTC circuit protector, the polymer material which is used in the system that makes up the electronic circuit protection increases its resistance. So due to the high resistance electrical path, the current flow to the motor will slow down, and through this high resistance, the circuit will be protected. Now when this, we can say, temperature of this circuit breaker cool downs, again the resistance is established to its initial value, and then the normal current starts to flow through the circuit. So in this way, the PTC type of circuit breakers are used in our automotive applications. Now, this is a typical, we can say, a layout where the PTC type of a circuit breakers are used. Okay, this is a fuse box, or we can say where the panel, where the circuit protectors are installed in the systems. So in the today's session, we have gone through testing of a fuse with a test light. We have seen the circuit breakers, the conventional type of a circuit breakers using a bimetallic strips, and another the PTC type of a circuit breaker which uses a polymer material whose resistance changes when the current flow exceeds than its amperage rating. We have seen the applications of the PTC type of a circuit breaker in the power window of a automobile. I hope you have understood these sessions If any students feel any doubts regarding these concepts, please feel free to drop me a mail. Thank you. Now, see you for the next lecture.